Most energy innovations don't fail because they don't work. They fail because the world around them isn't ready to change. We're taught to believe that good technology naturally wins. That if something is cleaner, cheaper, or more efficient, it will spread on its own. But when you look closely at the history of energy innovation, that belief starts to fall apart. For decades, engineers, scientists, and startups have introduced new ways to generate, store, and distribute energy. Many of them worked exactly as promised. Some were even objectively better than what we use today. And yet, they quietly disappeared, not because they were scams, not because they were impossible, but because something deeper was missing. People usually assume adoption is about performance. If an energy solution produces more power with less waste, the rest should take care of itself. But that's not how large systems behave. Especially systems that touch infrastructure, money, regulation, and habit all at once. Think about how many times energy has already been solved on paper. Revolutionary batteries, ultra-efficient engines, distributed generation models that remove the need for centralized grids. These ideas often reach a prototype stage. Some even reach small-scale deployment. Then progress stalls. So the usual response is to blame resistance. Oil companies, utilities, governments. And yes, those forces matter. But focusing only on resistance misses the more uncomfortable truth. Even when resistance is low, adoption can still fail. Imagine inventing a new type of fuel that works beautifully. It's cleaner and cheaper, but it requires new storage standards, new safety training, new distribution logistics, new maintenance knowledge. Suddenly, the innovation isn't just a product. It's a restructuring of an entire ecosystem. At that point, performance becomes secondary. People try to force these innovations into the existing system. They expect the grid, the market, and the user to adapt instantly. When that doesn't happen, the innovation is labeled ahead of its time and quietly shelved. This is where frustration sets in. Because from the inventor's perspective, the solution is obvious. The math works. The engineering checks out. The benefits are measurable. So why doesn't it spread? The more they push, the more confused they become. Grants are written. Demonstrations are built. Awareness campaigns are launched. Still, adoption barely moves. The mistake is assuming the barrier is knowledge. In reality, the barrier is structure. Energy systems are not just technical systems. They're social, financial, and regulatory structures that evolved over decades. Every component is optimized to work with everything else. Change one layer, and stress appears everywhere. Most failed energy innovations collide with this invisible layer. At first, explanations stay on the surface. People say the technology is too expensive, too complex, or not reliable enough. Those reasons sound logical, but they're often symptoms, not causes. Costs stay high because production never scales. Complexity feels overwhelming because support systems don't exist yet. Reliability is questioned because no one has decades of operational data. Then comes the turning point. The real issue isn't that these innovations don't work. It's that they demand systemic change before the system is willing to provide it. That's the part most people underestimate. Introducing a new energy technology is less like releasing a new phone and more like changing the language a country speaks. Even if the new language is more efficient, everyone else still speaks the old one. Communication breaks down before benefits can be felt. Once you see it this way, a pattern emerges. The energy innovations that survive don't just improve performance. They fit into existing structures, or they change them gradually enough that resistance stays manageable. They don't require everything else to change at once. This reframes the entire conversation. Instead of asking, is this technology better, the more useful question becomes, what does this technology force the system to change? That question is uncomfortable, because the answer is often a lot more than expected. It also explains why some innovations resurface decades later. When infrastructure, regulation, and market incentives finally align, suddenly the same idea looks viable. Not because the technology changed dramatically, but because the structure around it did. This perspective reduces blame. It's not that people are irrational. It's not that institutions are evil by default. It's that large systems protect stability above efficiency. Understanding this also changes how we evaluate new energy claims today. Instead of getting swept up by performance metrics alone, we can look at compatibility, training requirements, transition costs, dependency chains, not as a checklist, but as a way of seeing the full picture. Energy transitions don't fail at the point of invention. They fail at the point of integration. Once you recognize that, the history of failed energy innovations looks very different. Many weren't failures at all. They were misaligned with the moment they appeared in. That doesn't mean progress is impossible. It means progress is slower, more structural, and less dramatic than headlines suggest, and it explains why the future of energy often arrives quietly, in pieces, rather than all at once. If you want a deeper breakdown of how these structural forces shape which technologies survive and which disappear, there's a structured explanation linked in the description. It helps frame these transitions in a more realistic way. If this way of looking at energy innovation was useful, consider subscribing. More long-form breakdowns like this are coming. Thanks for watching.